This presentation will take you through the trial unique non-matching to location or tunnel task for either the rat or mouse touchscreen chambers. The task allows assessment of both spatial working memory and spatial pattern separation. Also, compared with many other non-matching to location tasks, it reduces confounding mediating responses, such as the rodent placing their tail to the correct side, and also offers a range of difficulties. Neural areas that can be assessed with the tunnel include the hippocampus, the cholinergic system, and NMDA pathways. Clinical areas that can be assessed using this task include Alzheimer's disease and schizophrenia. The optimal chambers for the task include a smooth-sided trapezoid wall to limit distractions within the chamber and keep the rodent focused on the task. A highly sensitive touchscreen capable of reliably detecting a mouse nose poke, even if the mouse does not press its nose up against the screen. A reward trough with light and nose poke detection that can be placed either at the rear of the chamber, as shown here, or in front of the touchscreen. A laser cut floor, and IR ambulatory beams to tell when the rodent is at the back or front of the chamber. When the reward trough is in the front of the screen, the IR beam is split to show which side of the screen is approached. The training procedures for the tunnel task are common to many of the other touchscreen tasks. It takes about 1 to 2 weeks to get the rodent to a stage where they are ready to be trained on the tunnel task itself. Lafayette Campden provide all of these tasks, along with the actual tunnel task itself, as a whole suite of tasks. Masks are placed in front of the touchscreen to form nose poke areas for responding to the task. The mouse uses 5 nose poke areas and the rat 15. I will now describe the mouse task. The rat is very similar except using 15 instead of 5 nose poke areas. The trial starts by lighting the reward tray or trough. When the mouse breaks the beam at the back of the chamber, the trough light is then extinguished. One of the 5 windows provided by the mask then lights up. This begins the sample stage. When the mouse nose pokes the lit window, the window goes dark and the delay begins. Once the delay period is finished, the reward tray light is lit again. Again, when the mouse breaks the beam at the back of the chamber, the tray light is extinguished. The choice stage then begins. The window that was lit before is lit again, along with one of the other windows. Because there is a choice of 5 positions, the new window could be left or right of the original lit window. This stops mediating behaviours. Also, the distance between the lit windows can be changed, giving a range of difficulties. The correct response is touching the new window. If this new window is touched, then that window will go dark, along with the other window, a tone will be played, and a reward will be given, usually strawberry milkshake. When the reward is delivered, the reward trough is again lit. When the mouse breaks the beam in the reward trough from taking the reward, then the trough light is extinguished and the ITI begins. After the intertrial interval, the reward trough is lit again to begin the next trial. If the mouse makes an incorrect choice, that is, he touches the sample window, then all the windows will go dark, the house light is illuminated and a timeout period will begin. After the timeout period, the house light is turned off and the ITI begins again. As before, after the intertrial interval, the reward trough lights again and the next trial begins. Here you can see a mouse performing the task. You can also see here our alternative open reward trough for animals that are tethered.